thing in software engineering. The word comes from a Netherlands person, Andrew Koenig, in 1995. He talked about specifically 50 practices in software architecture, software design, software project management, that initially appeared to be beneficial, but ultimately result in bad consequences that outweigh both for advantages. Okay, the definition we integrated from the end. We have something, we hoped for advantages. We have done something and we hope that it will bring us some advantages. But, as we can see, it doesn't happen. Because at the end we have bad consequences instead of hoped advantages. So why does it happen? That's the point. Well, we start with something and it looks good. It looks that we have benefit out of it. But unfortunately we do not have it over the time. There are plenty of anti-patterns. People have sometimes silly behavior. They do something, sometimes even knowing that it's bad, but they do it and they have good arguments for it, but at the end it's a disaster. The anti-pattern is a commonly used process, a structure, or a pattern of action that, despite initially appearing to be an appropriate and effective response to a problem, has more bad consequences than good ones. Another solution exists to the problem the anti-pattern is attempting to address. This solution is documented, repeatable, and proven to be effective where the anti-pattern is not. So, there must always be an alternative to it. An anti-pattern is describing an unwanted situation, but you need also have a solution to it. Yeah? You do something, you hope it's good, but at the end it is very bad. Okay, what to do? And now we have to take some actions to make this bad situation that arises because we have hoped it was a good one, but it wasn't, to bring it into a good condition. We will see a lot of examples, and we will see that we will laugh a little bit, I hope, because it's funny. There are categories, anti-patterns in project management, organizational, architecture and design, development, meta patterns, and user interface. I will just present some of them. Hi. So we start with project management anti-patterns. There is smoke and mirrors, bloatware, feature creep, scope creep, Brooks law, the death sprint, the death march, and we will start with the nicest picture I know, and I show to my students. It's an old, how do you say, old design. You have here projector, here's the mirror, and from the picture is done into the mirror, and the mirror is moving it into here, in this area. And here you produce smoke. So the mirror appears to be in the smoke. In old horror films, where we had no computer graphics to design ghosts and things like that, they use this technique to make ghosts appear. Okay, that is smoke. You must look in very old horror films. Then they appeared a ghost. It was obviously an actor, and the technique was exactly like this. They did the film before, they produced it, and they moved it into this smoke. Today, we don't need this anymore. People like Cesar Pozzo have computer graphics, and they do it just like this. But in the past, they had no computers, and they had to design these things like, with this effort. It's called smoke and mirrors. Here's the smoke, here's the mirror, and here's the picture. This comes into the mirror. So, smoke and mirrors is an old technique when an artifact seems to be in an empty room. Yes, it is empty, there's no room, but appears there. The phrase smoke and mirror has entered common English use to refer to any proposal that, when examined closely, proves to be an illusion. Talking about illusions. It's not there, but it seems to be that it's there. In informatics, it's just easy. The functions not yet ready, but who were faked. If we go with a product to the customer, they are not ready yet, we make smoke and mirrors to that the customer has the idea, everything's ready. So it's not a nice thing to behave, but we will do it. Okay, another thing is bloatware. Bloatware is used in several contexts. It is the term bloatware may be applied to software that has become bloated through inefficiency or accretion of features. So the term is used also to software pre-installed on a device, usually by the hardware manufacturer, that is most unwanted by the publishers. If you buy an MS Surface, they put an evaluation copy of MS Office on it. I don't use MS Office, so for me it's simply bloatware. And I will never buy it, but it's there. So we have an accumulation of unwanted and unused software elements that remain after partial and incomplete uninstallation. If you do an uninstall, plenty of software products still remain in parts on your computer. And that is bloatware. You don't want it, but it's there. So over the time, we have a lot of these bloatware things, and we are definitely we do not want it, but unfortunately we have to. It's there, and it's very difficult to get rid of it. This is just because the students like to learn from the slides. I have some slides where just the text is on it for the students, but I just told you that, so I move over. We have the feature creep, or scope creep. Feature creep is excessive, ongoing expansion or addition of new features in a product, especially in computer software, video games, and consumer and business electronics. These extra features go beyond the basic function of the product and can result in software bloat and overcomplication rather than simple design. So, if you think about, if you look a little bit back, and in the times we had more than just one MS Office. We had Lotus, Smart Suite, we had WordPerfect, and we had, I think, 2 or 3 more, Star Office. All these companies try to establish their tools with exactly feature creep. They put it all, every version had a lot of new features. And the problem was that they hadn't tested enough, there were a lot of faults in it, and you were not happy with the product. But they always told you, you need this product because it had beautiful new features, and it wasn't right. Scope creep is a little bit similar. It is something we call it in project management, to changes, continuous or uncontrolled growth in project scope at any point after the project begins. So if we look at large projects, we sometimes see that they tell us this project will last 2 years, and after 2 years not a lot is done. So it's another year, and you have to pay for it. At the beginning there were 10 people working on it, at the end there were 40 people working on it, and it costs more and costs more. And yes, the scope increased quite a lot, and it has several reasons for it. But generally, maybe it's not properly defined, maybe it's not properly documented, and it's not, of course, controlled. This is a funny law, Brooks' law, another anti-pattern. Frederick Brooks was the manager of the IBM, and he was the first one who really had the abilities, and he had the group of people he could look at. He was responsible for a large development of a large computer called IBM 360, and he had this group of people writing software for this large computer. And he had a lot of projects running with it, and he had stated some laws. And one of the most famous law is adding manpower to a late software project makes it later. Okay, in plenty of projects we usually do, it's the other way. If you have to put a lot of sand from this place to that place, and you see the manpower is not enough, you add some manpower. If you have 10 people working on putting a lot of sand from this place to that place, and you think, okay, we cannot manage this, we put another 10 on it. So we have 20 people moving sand from here to there, and it works. But in software development, it's not. It's different, and he had found out if you put people late to a software project, then it's becoming even later. So what can you do? The precondition is the project is already late. No, you cannot be finished right on time if you continue as you do. So what can you do? Well, you can put people earlier in the project. If you see it early that you will not finish right on time, then it's possible to add people early. Then you can educate them, they can be integrated into the project, into the team group, and then you maybe have an advantage of putting people in. Maybe you find out that the schedule was originally over optimistic. People tend to be optimistic. That's fine. If you are married and you are optimistic, that's fine, because the marriage will last longer if you are pessimistic. But in software projects, it's not a good choice. You have to be realistic. Yeah? So we tend to be optimistic, which is, in most cases of our life, is good, but in a scheduling project, it's not. Okay. Then what can you do with it? You have to tell the others, I was too optimistic. I made a fault. Sorry, we have to talk about another schedule. Today, we don't. Brooks comes from a time where we had the waterfall model, and we had this classical development, all the requirements, then the design, then the programming. Today, we don't develop like that anymore. We have agile methods, and the schedule in agile methods is a little bit different compared to schedule of real projects. Quantity, quality, and role of the added staff must be considered. Okay, good soft system developers and specialists can be better integrated instead of bad ones. Usually you don't have a lot of good programmers who want to add to projects. Usually you can put newbies in the project. They are cheap, they are available from the universities, and to put them into the project, but they do not help a lot. They are not good enough to produce good software. Okay, we have the tasks in plenty of projects are not clearly defined. So if you better define them and you can then delegate it to new staff, then it may be a profit for you. What can be good moved to new people is testing and quality assurance. Especially testing is good to new people. Plenty of companies have outsourced their testing. Because testing your own software is quite difficult, because you test that it's right. But testing always means you have to find out. You have to find errors, so you have to find maybe it's wrong what you programmed. Okay, what are solutions for Brooks' law? Continuous integration, test-driven development, iterative software development, different or agile software development, domain-driven design, another technique in software design, and well, you can reduce communication within the development group. If the problems do arise, people tend to communicate. Communication is fine, but if you just sit around and talk about the problems, you will not solve it. So sometimes it's necessary to reduce the communication and to bring the people to solve the real problems in the projects. This is another good, very, very good idea. Brooks found out that when a program is late, and the staff is getting nervous, then if you remove most of the developers of a project, or send them to Bermuda, if you have a, let's say, remaining 10 to 20%, then they will complete the software. So you have 20 people working on a project, and it doesn't work. So we use it by 20, up down to 20%, which means four are left. You choose the 4 best programmers or best developers you have, and they sit together and they will develop it very quickly. Because they know the software, they're able to do the job, and the communication processes are reduced to nearly nothing. It's unbelievable, but there are some from the literature we know some plans that it works. There is risk in it, but when Elon Musk took over Twitter, he kicked out, I think, 80% of the developers. So exactly he did this. He kicked out 80% and said the rest has to do the job. And the software is not worse than it was before. Okay. Another bad anti-pattern is death sprint. In the death sprint, software is delivered iteratively, that's fine. In this case, the development takes place in a far too short period of time. To the outside world, the project initially looks very successful as new versions and new features are completed again and again. However, the quality of this product suffers both visibility to the outside world and technically, although only the developers recognize it. So the quality decreases with each successful new iteration. A death sprint is typically something which occur in the modern so-called agile methods. Agile will have all these 3 or 4 week tasks, and at the end they had to deliver a software product. And what I saw with my student groups, with the first years we did this, they deliver every 4 months, 4 weeks, sorry, every 4 weeks they deliver a good product. Every 4 weeks. But when we look at the software, it was a disaster. There was no structure in it. They didn't use any software engineering. They did not any testing, and all this stuff they learned. I hope they learned from my lecture. Nothing I could see. So I changed. We don't make death sprints. We just have to think more about the structure of the software. Today they have to supply a software architecture. They have to provide testing strategies, test cases, automated testing, documentation, and all this stuff. And now it's much better. And they are not less productive, they are more productive, because over the month they develop, the software structure is better, so they can implement quicker, better parts of the software. And if you look at the literature, of course, the people who are telling you Agile is great and do everything is fine, they are in some cases right, but you will find also in the literature parts where people tell you, okay, we started and it was, at the beginning it was fine, but over the time we realized that the software had a disastrous internal structure. Okay, Agile development uses short sprints, and we have significant flaws in the architecture of many systems created this way. My use at the beginning, my projects at the university had this deficiency. Yes, a little bit more, a very bad word, death marsh. Comes from 2, in reality, in history, happening death marshes. One was 1914, happened far away from here. The Turks did a genocide to the Armenian people. Do you know this? You know it? You know? No, it was a very bad thing. In Turkey, we had this war. Okay? 1914 was the first war, beginning of First World War. The Turks were involved in this war, the Russians were involved in this war. And the Turks used this beginning of the war to kill, we don't know exactly how many, but we know for sure it was more than 1 million Armenian people. They killed the men and sent the women and the children on the death march. So they just had to walk. They didn't get any food, any drinks, anything. You see the people here with the guns, the Turks, and all the others are the Armenians. Yes, some years later, I don't have a picture similar to this. The Germans did the same with the Jews. At the end of the Second World War, when we knew we had lost the war, we had still plenty of people in the concentration camps. And so the American armies and the British armies invaded our country. So they closed the concentration camps and sent these people on a death march. Simply they let just them run as long as possible. If they could not walk anymore, they were killed. And at the end, only a small part of the people could survive. So this, unfortunately, is a very, very poor history of mankind. Here's one of these death marches. They went from concentration camp Sachsenhausen, which is here. It's a little bit north of Berlin. Somewhere here is Berlin. And they had to walk, as you can see here. And during that time, almost 6,000 people were murdered by the Nazis. In total, we had millions of people who were killed by the Nazis in concentration camps. Okay, in software engineering, fortunately, it's not as bad as this history, but it's still very bad. We have a project that involves grueling overwork and often potentially unrealistic expectations, and thus in many cases is destined to fail. We have unrealistic and overly optimistic expectations in scheduling or feature scope, and often results from a lack of appropriate documentation, relevant training, or outside expertise needed to complete the project. We have misunderstandings between parties, unresolved assumptions, mismatched expectations, and sometimes external change. So the management, what do? They try to let the people more work. 14 hours per day, 7 days, working a week, all by attempting to throw enough bodies at that, the problem. Adding people late to a project makes it even later. Plenty of people have burnout. People are trying to solve this problem. Instead of just thinking, maybe software engineering can help them. It looks like Caesar. This is a big ball of mud. You know this pattern? No? Okay. A big ball of mud is always created if you have no software architecture. There's no other chance. If you produce large amounts of software, let's say 100,000 lines of code, or 1 million lines of code, and you have no architecture. But you say, no, I have no idea about what to do, I don't know a proper software architecture. At the end, you will have a big ball of mud, which is software with a very, very strange structure. Drink. This is just what I told you. German. Okay. I can tell you. We'll stay here. I had 2 projects. I did some consulting. One was a project, they developed software for the police. One police department in a big town. And they implemented it there, and then police decided to implement it at other places too. But every department is a little bit different. So what they did, they implemented the software at another place and extended the software for the other department. At the end, they had 50 different installations in the area where I live, but just one piece of software. And every department got every line of code. That was one problem. The second problem was they had a big ball of mud, because they started to develop, had no idea about software architecture, and then one of the best students, maybe the best student we ever had, became responsible for this project. So he came and said, do you have any idea what to do? I said, yeah, I have an idea. You have to redesign the system. You have to find a new design of it, an architecture for the system. So we decided to make a project. And we decided to implement the OSGI Java component structure, which is a 24/7 abilities. The software can run 24/7 hours, 7 days a week. Even you change parts of the software, which was important because police software cannot be interrupted for hours to implement a new version. Second was, we tried to build large components of the software. But the software was so disastrous developed, it's quite impossible. So he went to his boss and said, we need half a year just to do nothing else than redesign. The boss said, no, we don't earn money with that. If you just sit around and develop a new version, no, we will not do that. We will not do what Netscape tried to do in the 90s and failed. You give me another solution. So my former student, decided to implement this OSGI, this component structure in the software, and then they were able to remove about 20% out of this big ball of mud. So the 80% is still in a big ball of mud. And he said, at the moment, he doesn't believe that they can solve it. They have to try to solve it over the years to make, let's say, 4 or 5 components out of 80% of the software. So they have 20%. It's a big improvement for us because we have some parts really separated from the rest. They have low coupling between these components, but there's still this 80% of software we have to handle it as a big ball of. The other one was better. The software was a little bit smaller. It was a software for a very specialized software. If you develop a new big chemical plant, really large, producing whatever chemical engineers do produce, you need to plan that. That is very, very special software. This software was developed, started in the 90s, and were developed and developed and developed. They had 3 different languages in it. They had bought software from an English company who got bankrupt, had to finish their work because of financial problems. So the company didn't exist anymore. And they just bought the rights for the software, but they said we cannot change it because we are not a graphic engine company. We just use it, but we know we cannot use this graphic engine long for the next years because it's old. So they had this problem that there was a ball of mud. They used different languages. They used this English graphic engine, which they know they could not use any longer. So there we had a project, and this was quite successful. It was possible to put this large big ball of mud in 3 nearly equal big parts. So we had 3 parts, and the main advantage of this, that we have these 3 parts, was that the graphic engine was limited in 1 part. So the next step in their development was that they have now the chance to exchange the graphic engine, this old graphic engine, to a new one. And they were very successful. They have now only 1 programming languages. They have a software architecture. They have a new graphic engine now, so they are quite happy with it. Well, the main point is if you do nothing about software architecture, you will always have a big ball of mud. There's no chance. If you just develop, you will have a big ball of mud. So sometimes even a bad architecture or an architectural pattern, to use it, is better than to do nothing. Okay, what can you do if you, or what is done if you have a big ball of mud? Plenty of companies simply go on developing. They just say, okay, it's a big ball of mud, but we cannot do anything against it. Yes. If you're a manager and you are there only for 2 or 3 years, you say, okay, in my period of time it will survive, and then I will leave the company, but the next one has a problem. You can develop a new version, but because the software systems are so large now, companies cannot afford that. So it's, in very, very rare cases, it's done. Do you know the company Netscape? You know it. If you say yes, you are old. If you say no, you are young. Netscape was very successful in the 90s, and the boss, Mark Andreessen, developed the first really good browser in the internet. It was a Netscape Navigator? Navigator, I think. It's Netscape Navigator. It was very, very successful, and so what did they do? They developed a big ball of mud. And they had to implement a lot of new features. Playing films, viewing pictures, different types of computers. It was an absolute brilliant story of a new company. But they had this problem: we have a big ball of mud. And Mark Andreessen realized we have a big ball of mud. So 2 things happened, unfortunately for him, at the same time. The company Netscape decided to develop the Netscape Communicator, a new version, not a big ball of mud, but a well-designed browser. And at the same time, Microsoft brought the Internet Explorer. Microsoft had a lot of people working on it, had a lot of money. So within, I think we would say within a year, Microsoft got all the market shares and Netscape simply disappeared. Because the communicator came too late, and the Netscape Navigator was not developed anymore. The communicator came too late to the market, and Microsoft had all the shares. Now it's different. I think now most people use Google. Some use Bing, Microsoft Bing. I use Firefox, which is okay as well. The best you can do is refactoring. You have to think about what can I do with a big ball of mud. You have to think about a proper architecture for it. and you have to try to develop it in the direction of this architecture. There is definitely no other chance. If you try to survive with a big ball of mud, you will not survive. So at the end, Mark Andreessen had no chance with this company to continue developing the Netscape Navigator. No chance against the Internet Explorer to develop the communicator. He was too late to develop the market. So he lost. Well, he was rich enough now to pull a discount. Okay, this is just to read that you can read it, what I already said to you. Yes, the best is the refactoring. Some things you can do. We try to reduce the dependencies of the components, but from the two projects I did consulting, the first thing you have to do is to think about what architecture will we reach. What is the architecture of our system? And the one project was successful. They had at the end 3 large subsystems with low coupling in between. And the other project at least had removed 20% of the code out of this big ball. It's God. Okay, it's written. It's a D here. In Germany it's double T, God. But in English it's God. In Portuguese it's Deus. Deus. Yes, it's Latin. Deus. So the God object. Yes, an object that knows too much or does too much. Sometimes in a team you have one good programmer, one who likes to have everything, good things to do in his programs. So he concentrates all these good stuff in his programs. Sometimes he is concentrating it to just one object. So you have one large object, the God object, that knows too much and does too much. I said, no, people don't do that. Why? Why should they do that? But exactly, we had a student project where exactly that happened. We had one very good programmer, he's now a professor in the Netherlands, much better than the other ones, and he started to develop a God project, a God object. The other one were quite happy with the situation because if they had a problem, they went to him and said, this problem, no problem, just handle me over the parameters and I will give you the solution back. And he integrated that all in one object. So with exactly the situation of one God object. And now he's professor for software architecture. It's very interesting. And I met him at an alumni meeting at our university, and I told him the story that he made this God object. And he said, yes, I remember very much, because I know now that it was completely wrong to do this like this. Yeah, a God object is never a good solution. It's something. It's a big ball of mud inside the system. So you have a lot of other things, but then you have a big ball of mud inside the system. Here's what I told you. This is fine. Spaghetti code. In the past, when you had structured programming, it happened more than now with object-oriented program. But it still happens. It's what I call the little brother of big ball of mud. You have one large object, one large class, or one large operation, where the control flow is just like a pot of spaghetti. So you have, yes, it's nice to eat, but it's not nice to handle it as a program. Because if you have go-tos in the program and an undefined sequence of operations, then yes, you have problems with how to handle it. Many different. Why did it happen? Well, I think in object-oriented programming it's less common. In structured programming it happens quite a lot of time. How can we define it? Okay. Object-oriented programming, for example, offers various ways to distribute and reuse code within classes and across class boundaries. Spaghetti code can only be avoided through consistent adherence to the paradigms of object-oriented programming. Object-oriented programming gives you the chance to avoid spaghetti code, but if you are not used to these object-oriented programming paradigms, then you have the problems to design and you have to use spaghetti code. Ravioli code. It's often as a result of too many little classes. So you always have the problem if you design a system, the lines of code do increase. How many classes do I have to build? And people sometimes tend to develop small classes, two small classes. So each class is doing some little thing. Well, in some sense, it's not bad, but if you have very, very large systems, it's not so good to design too many little classes. And because you have to, if you want to understand the code, you have to go to plenty of classes to understand what is going on. Sometimes it's good to put things together which are good to put together. Lavagna code. It's the Italian part of the lecture. Reference to code whose layers are so complicated and intertwined that making a change in one layer would necessitate changes in other. Excuse me, cough. Next time I will come to Brazil when it's hot. I don't get a cough. Yeah. So the point here is you have this beautiful lasagna, and you have layers in the code. And if you change one layer, you have to change, make changes in all layers. Yesterday I told you about the layering architecture. And the point is in layering architecture that you try exactly to avoid to change one layer, then only the layer above and the layer below has to be affected. If you do it the other way, that more than one layer is each direction is affected, then it's not a good layering. So it's the same here with lasagna code. You have these layers of lasagna and you have to be careful that you have to change only one layer and that's the next one, and not every layer. Macaroni code. Macaronic language is any expression using a mixture of languages. You see we have here a mixture of pasta. If you use a mixture of computer languages in a small area of the system, this is not a good solution because people don't know so many languages very well. If I would ask you what language do you program best, maybe you would say Java, you would say ++, and you may say Python. But no one is good in Python and C++ and in Java and in Smalltalk and in C and in whatever you think, TypeScript. So if you mix code, if you mix code as we have here, mix the middle, the pasta, then you have these problems to occur. That people have to change the code. I'm a Java programmer, and then I look at TypeScript, or I look at Python, or I look at any other. And I have to ask someone maybe, or I have to look what is this code doing. Yeah? So we have caused problems if you use macaroni code. Sumo marriage. Do you know Sumo? I have this picture here. This beautiful man, strong man. In the past, we had these client-server systems. There was the database, and the people organizing the database were the bosses in the software development department. database was the most important. So what they did, they tried to make their importance by connecting the clients, to make the clients dependent on the database. So they put a lot of logic in the database in the form of the database own programming language. So instead of using the database just as a database, they put a lot of code in the database. Like IBM or what was the other one? Relational databases, DB2, Oracle. They have their own programming languages, and the database programmers tend to program in this language. Connected this program logic very close to the database. And that is not good. Database is simply a storage of persistent data. So they got the Sumo problem. That if you want to move this application to something from other places, for example, there was a time when you had to connect the internet, it was not possible to bring this database to the internet because all this code were in the database and it was not possible to use it on the internet. So they had systems where it's called Sumo marriage, I don't know why. Because there are two fat people, the database and the clients, and but then, yeah, they fight against each other, and the result is maybe not good. Interesting sport. Copy and paste is another bad anti-pattern. Instead of use polymorphism, programmers tend to simply do copy and paste. It's quick. It works at the first round. Sometimes they change the code a little bit, sometimes not. So what is happening all the time? Maybe you have to change something in this code. And you have copied it 10 times. Maybe you have to change the code 10 times. It's an absolute disaster. And if you don't forget one or two, this will cause problems. It's an absolute disaster. So object-oriented programming gives you a lot of possibilities to avoid copy and paste. Even procedural programming offers you the chance to use a common function. Now we have polymorphism and you don't need to do copy and paste. So if you're a programmer and you say, okay, I do copy and paste, stop, think about the problem and do it the other way. Lava flow is another word for dead code. That's a good story. Years ago, I met someone on a conference, and he said when he started to work for an American company developing software for the Department of Defense, they gave him part of code. And he was responsible for this part of code, and he felt very important. I'm a new programmer, I'm here, I have a large amount of code where I'm responsible for. But he got new requirements, he implemented them. Then one day he realized that this code is never used. It was just there, and no one did use it anymore. So he went to his boss and said, "Boss, I'm programming on a piece of code no one does need." And the boss said, "Yes, I know, but we get money for it. So that's the reason why you do it. We earn money. That's good, it's very good. And you can train yourself, and if you have learned all this stuff, then we can put it in another project." So this is a funny story, but the idea that you have dead code in your code, well, when I developed software, and I had to replace a part of software by another, better solution, for example, or a different solution. Many times I did not delete it. Sometimes I commented it out, sometimes I coded around it, but to delete it was very hard for me. Because in the past I spent times on it. I spent an idea on it. And just to delete it, it's gone, was difficult for me to do. So I had to laugh when I first read about lava code, lava flow. So you have this old code, and well, I know it's old code, but the next one who has to change the program doesn't know. So he thinks, why is this code still there? Why is it not out-commented? It looks good. Let's reuse it, or something like that. So that code is something, well, you should maybe at least write, I did it, I commented it out, or something like that. And if it's not used during the next 3 months, we have to delete it. So the next one, read, okay, I can delete it now because it's used. Because in the first round to delete it, I still think it's very, very difficult. And I asked my student, they said, no, we cannot delete the code we just read. We have to keep it because maybe it's good code. Okay, this is an interesting point. The old Aristotle is the origin. Classification. We have exigential complexity and essential complexity. Exigential complexity is something related to problems which engineers create and can fix. The details of writing, optimizing assembly code, or the delays caused by batch processing. So we have a problem which is complex, but we can solve it. Or we can avoid to implement exigential complexity. Essential complexity is caused by the problem itself. So the problem itself is complex. It's different. One is the problem, and the problem is complex, and you cannot remove this complexity. You have to deal with it. For example, with your program, you may have complex problems, but you cannot reduce this complexity because it's there. You have to cope with it. But many times, people add complexity which is not necessary to add. People may make faults, don't really think about it. For example, we have in this Java enterprise world, we have a very good matching between the Java object-oriented world and the database. We have an object-related mapping to the database. And if you know how to program that, the application server will do a lot of the job for you. If you don't know, you just SQL programming and you do the job all by yourself. So this problem of the complexity the programmer is putting into the code is accidental. He could solve it using other technique. The complexity itself was not so big as he did it. Do you understand what I mean? How to connect to the database is the problem. Java Enterprise or now Jakarta Enterprise has a very good solution to do it. The application server has a technique to improve the connection to the database. It's very easy for you to use it. So if you do SQL programming, it's accidental. You have to put the complexity into the program which is not necessary. The essential complexity is very low because you can use this Java Enterprise thing. In the past, it was not available. So in the past, it was essential complexity, and now it moved to accidental complexity because we have a better solution. Just code that. Okay, ambitious viewpoints. We have a representation of a model without specification, without its specific viewpoint. At different points of the development, you have different viewpoints on the project, and different people have different views on the viewpoint, on the product. So first is the business viewpoint. This is the end users, and one who pays for the software or on the software. That's the specification viewpoint. That is what the architects and the analysts, architects and the designers do. That's the implementation viewpoint. That is how you internally implement things. Every viewpoint, because it's a viewpoint, have a different view on the system. They create different models, different around different problems to arise, different problems have to arise, solve different. But this is fine. A magic number. What is a magic number? 3 different meanings in programming. Originally, it comes from the unit word. This is a special value that marks a certain file format at the beginning of the file. Okay, it's for Unix important, for normal programmers it's not. The second one is a conspicuous value to mark a register or memory area that is later to be examined for errors by means of a debugger. Such marking magic numbers are mostly selected from the following domains: the ASCII code, the hexadecimal representation of numbers, or sometimes hex speak is used. Not so important on high-level programming languages. The last one is the most interesting thing. Numerical value appearing in the source code of program, also called hard-coded values. Those meanings are immediately recognizable. It means it is magic. But magic numbers should be avoided and replaced by well-named constant declinations whose names clearly indicate meaning and origin. I will give you some examples. I have to tell you that. In Germany we have what we call Mehrwertsteuer. It's a tax put on every good. In Germany you have 2 values for it. It's an ordinary tax, 90%, 19%. Okay. I tell my students that there's only one reason that your handy can make noise. That is when your girlfriend is getting a baby. Then you can make any noise you want and you will give you applause when you leave the room. Never happened. Okay. So we have these value-added, this has value-added tax. Let's put it on any good. We have two value-added taxes. One is 19%, the other one is 7%. 7% is on good like water, bread, pasta, okay? And the other one is on electrical devices and things like that. Over the years, this value has changed. I remember we had, before 19 we had 16, I remember we had 14, we had 11. If you hard code 11 in your code as this tax value, then you have this magic number, just 11. And if you have not properly defined it, no one knows what 11 is, because some years later it's 19. So you look at the code and say, why it's here 11? It should be 19, you are clever. So you have to remove these magic numbers out of your code. Don't use magic numbers, hard-coded magic numbers. It's not 42. 42 can be used, because it's the solution of every problem. Or bleeding edge technology. Yes, anytime you are a company responsible for integrating new technology, you have to think about, shall we use this new technology? Shall we use, for example, NoSQL databases instead of our relational databases? It's a very common question at the moment. So, if you are very early to integrate a new technology, you will bleed, because all the problems that arise implementing a new technology in companies, you will have, if you are the first or among the first ones in this process. So companies can make what's called greater progress, but at the cost of greater risk. If it doesn't work, you have spent a lot of money, and it's gone. There's a good story of Volvo. Usually companies do not talk about what went wrong. But this time Volvo did. They, in the 80s, I think, long time ago, IBM went to the companies and said, we implement a system in your company that will give you any number you need to control the company. And I know that because they came to Daimler-Benz as well, and our top level managers gave it to the research and said to us, what do you think about it? And we did some small projects, and we said, no, we don't think it's possible. And exactly, we didn't do it. Daimler-Benz didn't do this, but Volvo did. Volvo implemented this IBM idea in its company. So they had a lot of programmers, and they programmed quite nice things, but they spent money and money and money, and they didn't finish. After some years, the management changed. So the new manager asked the people, what about this project? When will you finish? Oh, we are nearly ready. Okay, nearly ready. When are you ready? You are now working some years on the project. When it's ready? Yes, we have a small problem. Okay, he said, what is the problem? Yes, he said, the problem is always buying and selling plants, parts of the company. And if we have to integrate such a plant or a daughter company, it costs us a year of work. Okay, says the manager, and what is the problem? Yes, the problem is that we buy or sell 2 companies per year. So we can never get ready. And then he decided to stop the project. Because they had said, we will do this, it will bring the company to the front of the world, and all this stuff managers tell you. They had to document that they do finish it. So it's one of the rare examples that a company told the world, we did something wrong. We tried to implement a new technology, and it didn't work. And we spent lots of money on it, and it didn't work, and we finished the project. So they tried to have improvement in their company, greater progress, but the risk was too great, and at the end they had to stop the project. Okay. This is just a dependent. Yes, in companies, where are the good programmers? Interesting point. Usually, if you have a company, several departments, the good ones concentrate in one area. Because if you are good, you like to work with other good people. And if you are not so good, you try to avoid to work with other good ones. We say someone with one eye is much better than a blind one. But he will not can compare with one who can see with 2 eyes. So at the end you have this programmer experience clumping. The good ones concentrate on one area. They have work, good life. They can release their products quite fine. They have good remarks. Everything's fine. So the other do struggle a little bit. So now it's happening that companies use new people and they hire inexperienced programmers. They work for low salary, and yes, in a group of people, there were times when management did not like the programmers, when they got poor working conditions, and the inexperienced programmers sat there and worked together. And we have sometimes you have experienced specialists in it, when it's not this clumping structure. If they see they have to work for all these new ones, they change the job, or they clump in some parts of the package. So you need to as a company, you have to try to avoid these experience clumping. In the company, when I started to work with Daimler, I came to an area where they had very, very good programmers. So I had this advantage to work in a group with very good ones. So I could develop myself a lot, and after some time they gave me the opportunity to change, to move from the development to the research part of the company, where I also had the advantage to work with a lot of very, very good people. Or maybe the best group I ever worked with. Okay, programmer experience clumping is not limited to programmers, non-IT departments can. Okay, software erosion. Also software decay or software rot refers to the gradual deterioration of existing software. So you have software you develop and develop and develop, and over the time you have a decline in performance, you have difficulties in adaptability to new situations, an increase due to the accumulation of program errors as well as incompatibilities with new and future software environments. Let's start with the last one. Software is not running, do software get old? Well, from the physical point, not. Because it's just an amount of 0 and 1s. So it's never getting old. But the environment has changed. So the software cannot work as good as in the past into other environments. Old people have problems to cope with changing in their environment. That's with software the same. People are still the same in some sense, but they have problems to cope with their environment. So new software environments, you have to change the software to adapt it to these new ones. Accumulation of program errors. There was a very, very destructive view on software errors in the past. Someone said, we have always errors in software, we know that. If you program a lot of code, there are errors in it. If someone is telling me we have a piece of software, there is no error in it, it's a lie. There are always errors in it. You have to accept that. So then, I think the IBM group, was it? They made a test. They tried to find out if they remove an error. You have found an error in it. You did localize the error, you changed the software, so that this error didn't occur anymore. How many new errors do you put into the software when you remove one? So we hope it's less than one, but in plenty of cases we found out it's more than one. So we remove one error and we put more than one error in the software. The worst case was two new errors in the software while you remove one. So that's quite a big problem. If we remove errors, you have to look not to introduce new ones. Okay, performance problems, it's not the case anymore so nowadays, because we have CPUs very, very fast. You have 8 kernels and something like that, and even in a small mobile phone. So performance is not so much the problem anymore. Okay, that's it. So, yeah, a lot of things, but just a small part of the anti-pattern world. I think the most important is that you have to realize the big ball of mud problem. If you decide not to have an architecture on your system, you will at the end have a big ball of mud. Cannot avoid it. It's impossible. You need to have an idea how to structure your software. If you don't have it, you have a big ball of mud. That's, I think, the most important thing. And I would say, why do we do software architecture? At the end, we have large systems, very large systems, incredible large systems. And if we don't do anything, we have a big ball of mud. So we have to think about how we structure this software. There's no chance to say, well, we don't need it. If you don't say you don't want to, it's not necessary, you will have end in a big ball of mud. So you have to think, at least short after the beginning of the development, okay, we get some experiences, to develop new software, what architecture do we use? And even the bad architecture is better than no architecture. For example, if you say, okay, I use a blackboard, instead of, let's say, for layering would be better, but you use blackboard, you have an idea of an architecture. And if you decide later, blackboard is not so good, I have to move it to an end-tier architecture. It's easier because you already have components, and you can reassemble components better if you have already components. If you have a big ball of mud, you can reassemble nothing because it's just a big ball of mud. And if you have student projects, I thought in some rooms there are projects running. I'm sure if they have the no architecture, they are producing a big ball of mud. I would bet anything. Because if they have no idea of a structure, there is no structure. Okay. If you have any questions, I will answer. If you have no questions, I say thank you very much for listening. Okay, thank you. Now we can go to your student projects and I show you the big ball of mud.
No.
No?
No, you cannot see that.
You don't want to see that?
No, you cannot see that.
Oh, you cannot? Because it's military?
No, because it's a huge ball of mud project. It's not that. Of course, yeah, certainly we have some big issues, but sometimes we spend some months trying to clean up code and remove unused codes. We do very often in the project to try to maintain it simple, but when it becomes large, it's nearly impossible, as I said, to avoid the ball of mud, because sometimes.
No, the point is you have no idea of an architecture. That's the point, Robert.
Yes.
You need the idea of an architecture, then you can order the code.
But to have an architecture, you have to plan everything in advance.
No, not really.
More or less, but at least.
Of course, it's good if you know it as early as possible. But if you, at the end, if you want to change the code, if you think, okay, we have a big ball of mud, we must move to another structure, you need an idea of how the architecture should look like.
I remember the day that we started the project. It was me and two students, and we were trying to do something very simple and to implement, to try to understand, but not really the project. It's just a small point. And then it started growing, and then we have server and client and putting together and replacing network system and replacing that and replacing, put new one, try new technologies, and a lot of features, every day a lot of features, and and shit happens.
Yes, but yeah. You have to cope with it. That's the problem. Can you sleep well?
Yes.
Okay, that's good. If you're in a private company, sometimes you cannot speak well. Because if it's getting worse, the boss says, you know where the door is, I need a new one that does the job better than you. We had a colleague, I think somewhere in, let's say 1990, and we have to decide which object-oriented language we will use in the Daimler-Benz company. Because the company said, okay, we will not use C++ here and Smalltalk and Java was not there at that moment. So the choice was at least between C++ and Smalltalk. And he propagated Smalltalk. And then the company said, okay, we will make 2 projects and we will look how they run. So there was one Smalltalk and one C++ project. Both finished, both were okay. Then they were brought on the machines they had to run for the users. And the C++ project was fast. The Smalltalk 80 project was very slow. It was very good, but it was very, very slow. So it was one of my friends. He said, yes, we have to buy faster computers. And then the manager said, do you know how many computers we would have to buy? Over the years we can do that, but now we cannot afford to buy 100,000. At that time, PCs was quite expensive, not cheap as they are now. We cannot buy 100,000 new personal computers just that your Smalltalk 80 programs can run on them. So at the end, that was the end of his career in the company. They don't kicked him out, but he got an unimportant job. So later he quit and went to a university. So we always have to take decisions at a special point, and yes, if you have this project with a big ball of mud, you have to think about an architecture.
And the problem that in this project we have a lot of C# code and
C#.
Okay. And at the beginning we have some C++ and C#. Then we move everything to C#, and we use a game engine. That's a good and bad part, because good because it's easier, but the bad part is that a lot of code you don't have access. It's complex to understand, and also you have a lot of computer graphics sites, so a lot of shaders and algorithms that run inside the video card, some code that runs on CPU and distributed system. So it's many different kinds of codes and black boxes in the process, because Unity is a black box. Some parts of the code you don't know how it works. So both muds everywhere. And nothing can be done. There is no solution.
There's always a solution.
I don't know.
Cesar, believe me, there's always a solution. Maybe it's not a 100% solution, but you can move this to architecture better than it is now, I'm sure.
It's not bad, but
it's not good.
It's difficult. Maybe.
Something in between.
Yes, I think it's good, but the problem is that it's huge. So when it can be huge, it's difficult to manage every aspect of the simulation.
So you have to develop separated subsystems, loosely
Maybe
coupled
start from
subsystems.
scratch again.
No, you have to. You have to refactor it. I know it's difficult. I know it's difficult. Yes, I told you that one of the companies said we cannot make this process to restructure this big ball of mud into nicely, well-designed subsystems. We have to still have 80% of the code in one big ball of mud.
Yes, sometimes we because this project has many parts. I have most we think more related to geographical information system, maps and coordinates, and there are some parts that are more related to user interface. And we have a lot of tools And you look at them and you say, this tool is very complex, but we need to spend a lot of effort and money to refactor it. So okay, it's working, great. So
Okay,
a lot of code that's not used anymore, possibly, but no problem, it's working.
Do you know what a fool with a tool is? A fool with a tool.
Full?
What? A fool.
Full,
A fool. A stupid person. A fool with a tool. What is it? What is it? It's still a fool. The tool doesn't make him clever. And the better one is a fool with a tool is a well-equipped fool.
Well,
A well-equipped. Oh, it's a good. Is it wonderful? It's well-equipped now, but it's still a fool. It's just a joke at the end. Thank you very much for especially you.